Fire, air, earth, water, the elemental substances of our world, and since ancient times, only one craftsman has worked all four. The blacksmith. His hearth contained fire, his bellows breathed air, the black metal was part of the earth, and water was needed to quench the red-hot iron, and iron was the key to the development of civilization.
Communities benefited from iron because iron was a lot harder than what had been previously used, which was copper and bronze. And because the copper and bronze had to be resharpened on a more regular basis, the iron was stronger, harder, and more efficient for chopping down trees and using as ploughshares and just tools in general.
Ironworking skills existed in Britain before the Romans and developed under the Vikings and Anglo-Saxons. Early workings used ore from surface deposits or cliff faces. It was first dried and cleaned by pit roasting, then broken into small nuggets for intense heating or smelting to remove impurities known as slag. The ore was set with alternative layers of charcoal and heated up to 1500 degrees centigrade in a chimney-shaped clay furnace about 4 feet high and 16 inches across. Molten iron collected in a pit at the base of the furnace where slag was tapped off, leaving the smith with a lump of iron known as a bloom. This was then reheated and beaten to remove any contamination. The Saxons learned that carbon from charcoal could be absorbed by the hot iron, making it much harder, though more brittle. Techniques were developed to layer the material along the edges of axes and swords, retaining the flexibility of iron, but allowing a keen edge capable of sharpening. In ancient times, the most important tool made by the smith was the knife, an instrument synonymous with life and death. The forging of nails and other fixings allowed for a more economic use of timber and other materials. Iron hardware of simple, functional form, or decorated to the taste of the customer, enabled the use of windows and doors as standard items in any structure. Large strap door hinges, butterfly hinges for furniture, and many other handles and fasteners were handmade until the end of the 18th century. Food preparation for an ever-increasing population was transformed by the smith's ingenuity as cooking apparatus and utensils made from beaten and riveted sheets harnessed the heat of the fire.
They're very heavy to hold. You need nearly 2 hands if it's a full pot to actually put it on the stove. So they're very heavy. You won't get any dings or bangs on those saucepans. They're very strong, very durable.
Last forever.
I think so, yeah. I think they outlast me, definitely.
Apart from riveting, fire welding was the only method of joining 2 pieces of metal together. 2 pieces of white-hot iron on the brink of destruction were withdrawn from the heat and beaten together. Axes were made by folding iron around a socket and welding the blade together with a hardened insert. Highly skilled smiths produced delicate, artistic artifacts for a prestigious or ceremonial use, which can still be seen today. Their artistic talents were given a free rein to attract the public eye. In traditional communities, the blacksmith shared a status similar to that of physicians and priests.
Well, there is a story, and it's sometimes ascribed to King Arthur and sometimes ascribed to King Alfred, the one who built the cakes. And it's about a competition that he held to find who was the best craftsman in his kingdom. And he awarded the prize to his tailor, who supplied him with a very nice suit of clothes. This annoyed the blacksmith so much that he decided to go on strike. And after a while, King Alfred had to call the blacksmith in and admit that he was the best craftsman because he made all the tools for the other craftsmen to do their work. Now this shows you 2 things. One, that blacksmiths were very important to Anglo-Saxon and medieval society. And the other thing is it was probably a story put about by blacksmiths to increase their reputation.
The blacksmith's skills were required to weld and fit wagon tyres and hub rings, to shoe horses and oxen, and provide all the metal fixings for a horse-drawn society.
The blacksmith was very important because every bit of the metal that we use was produced by the blacksmith. Take, for instance, this chain here, which I use to couple the horse to the cart. If any part of this chain was broken, the hook broke or the link broke, it would have had to gone back to the blacksmith to be repaired or replaced. All the links and the hooks were all hand forged and fire welded by the blacksmith.
So without him, everything would have ground to a halt?
Pretty much. There would have been a lot of dangerous pieces about that the farmers would have tried to fabricate themselves. It's an art that's lost now, really.
He also made and repaired items where the application of custom wrought iron was needed to extend the life of a weakened item.
The skill of the blacksmith is as relevant today as it was 100 years ago, because with this area of ancient framing we've been able to strengthen it and leave it in place without having to demolish and dismantle, and the pattern of age and smoke blackening will survive for generations to come, and so the whole story of occupation of this house will be assisted by the work of the blacksmith.
Ships' blacksmiths and armourers carried their trade to foreign lands. Back home there was an ever-increasing demand for their work in the pursuance of everyday life and occasionally death.
The Industrial Revolution produced dynasties of iron founders which are very well known, the Darbys, the Botfields and others. And here at Downton what we have is very early experimentation with cast iron. The Downton Forge produced exemplary work during the 17th century, and the tombs which survive, whilst they've had 300 years of weathering, are still very crisp and exemplary in the iron founder's art.
Demand for iron had a major impact on the countryside. Forges sprang up in woodland areas which supplied the necessary charcoal. By the 18th century, wood supplies became depleted as land was cleared for farming. Churchill Forge near Kidderminster continued operations until the 1970s. Today it's run by a trust.
It is an important place, and we felt that if once the machinery stops, then that's it. It will start to deteriorate like anything. Once you stop using it, it starts to go off the boil and things start to happen to the stuff. So we thought that we could probably keep it going and in our small way would preserve it. But of course since then things have moved on a touch, and we've had the Churchill Forge Trust who've been formed with volunteers who've come down here and maintain the machine. Not worked it, because nowadays we haven't got a furnace as such, but they've come down and they've worked on it and they've done the maintenance part of it.
In 1709, Abraham Darby I succeeded in smelting iron using coke and laid the foundations for the industrialisation of metalworking. In 1779, the world's first iron bridge was built over the Severn at Coalbrookdale. And in 1797, Charles Baige constructed the first iron frame building at Ditherington, Shrewsbury. His textile mill was the forerunner for skyscrapers all over the world.
Improvements in smelting iron throughout the 18th century continued until 1784, when Henry Court developed a process of passing the molten iron through heavy rollers. This greatly speeded the process and also meant that you could produce iron of varying thicknesses and varying sizes.
Sophisticated casting technology allowed for the mass production of architectural designs. Public lighting and other utilities provided scope for elaboration. The refinement of castings and fittings allowed for repair and restraint of existing buildings and the carrying of loads previously unachievable.
What we have here is a brick building where effectively the ground floor was removed to create 2 shop fronts and an archway through to the rear. What that meant was there were tremendous loads of masonry suspended effectively in mid-air, and that caused great stresses on the building. To be able to restrain the frontage and to allow it to all hang together, the development of castings allowed for these plates and the wrought ironwork to hold the front of the building to the back of the building and so give it a structural integrity. Without that, the building would have effectively collapsed. And with the insertion of the shop fronts and large areas of glass, again there was a need for support, and the development of cast iron columns again provided that necessary strengthening at this level. And here at Marston's Mill, the former milling of the corn produced great stresses on the building, and the columns provided the support during the working life to enable the mill to survive for over 100 years in use. And when it went out of use today, the imaginative use of iron has unlocked the potential for a new and beneficial use. The Housing Association, which provides accommodation on all the floors, has done a tremendous job in giving this building a future.
Castings developed for tools and machinery stimulated the creation of local foundries and workshops which stamped their names and addresses on their products. Other premises, like Ludlow's first automobile workshop, dealt with metalwork of the moving variety.
They bring the car in, the car bodywork was loosened. It was then the car was taken to a garage in Old Street, the other end of town, to a body shop. The body was lifted off, and then roped a soap box onto the chassis of the car, drove it back here. They repaired the mechanical side, and the people in Old Street did all the bodywork, the trimmings, the doors, hinges, everything. When they were both ready, they then took the chassis back over to Old Street and they assembled them back together. The car was service ready for another 12 months.
Something different from today.
Something totally different today. Car comes in today and they expect it back at dinner time, fully serviced.
Britain in the early 19th century was at the heart of the greatest empire the world has ever known. Its people, its industry, its commerce all demanded buildings and shelter to facilitate expansion on a grand scale. Towns and cities became vast building sites as quarries and brickworks laboured to supply traditional demands. But the Victorian age was the age of iron, by now a cheap mass-produced material which could be assembled to span large areas with minimal support. The invention of corrugated sheeting in 1828 provided the means to clad such buildings, enabling the construction of cheap prefabricated structures in foreign lands.
Closer to home, the flexibility of iron cladding was exploited for so many uses, for worship, for accommodation, for industry, for agriculture, and here for recreation at Tenbury Wells. The iron sheets, which were galvanised, have lasted way beyond their expected life, and now, some 100 years later, we can still enjoy the results of the efforts and the ornamentation that was put into these buildings.
In 1856, Sir Henry Bessemer's tilting furnace directed high-pressure air into molten iron, intensifying the heat and burning out impurities, notably carbon. This allowed production of a uniform, malleable product. The development of giant rolling mills allowed for huge architect-designed steel-frame structures which have transformed our towns and cities. Steel and its alloys has provided the foundation of modern-age development, but where this regularity is coupled with bland design, the effect can be injurious to a sensitive historic environment. But where the design has originality...
In St Lawrence's, we saw the skill of the blacksmith, articulating the reverence around the tombs and the celebration of those that were located there. But today, we still have that capability, and whilst it's a contemporary twist, the blacksmith here has used the metal, the copper, in such a way that we still have the grace and the significance of what's been celebrated, and it's now a major piece of public art in the town.
The conservation of metalwork is largely a battle against corrosion, or the reversion of metal to its original form. Rusting needs air or moisture to support the oxidizing process, so prevention generally involves the application of a protective coating. This is normally a paint containing embodied oils on non-ferrous metal, a pigment and a binder to hold it together. Following health concerns over lead-based paints, its use is now restricted to Grade 1 and Grade 2 star listed buildings. Whilst good wrought iron can be extremely resilient, water can penetrate weak laminations, causing expansion as it sheds wafer-thin layers of iron. This can disfigure and eventually destroy the item, and in hidden locations, unseen corrosion of wrought iron fixings can blow apart large stone blocks and decorative items. Dedicated companies are engaged in replacing defective material and the stabilization of metal inserts. In recent years, a method known as cathodic protection has proved very successful. This involves the provision of an electric charge to reverse the polarity of the metal and stem the rusting process. The use of metal detectors has been invaluable in locating internal fixings, and specialist advice is available from English Heritage.
A lot of traditional ironwork was lost during the Second World War to the war effort. This included many railings from public spaces, domestic ironwork, and other features which are sorely missed today. Sadly, much of the material removed at this time was scrapped as it was unusable for arms production.
Deterioration of cast iron can be the result of corrosion, but often its brittle nature can lead to fracture, particularly as a result of impact or eccentric loading. Today, some surviving iron features, like the sluice gates at Ludlow's Mill Street Weir, are more than 170 years old.
Well, of course, the outcome of the restoration of the sluice gates has been fantastic. And one of the main items depended on whether we could get the restoration of the cogs and the wheels that were actually manufactured in 1833. And when we found that something could be made in the same fashion as in 1833, it was absolutely fantastic.
Because wherever you go now, people say, oh, they couldn't do that these days.
Well, of course they can, and that is a credit to the English and British manufacturing system.
And while the numbers of traditional cast manufacturers have declined during the past century, there still exists a handful of companies capable of achieving the highest standard of repair and replacement work, people with a passion.
I suppose it's the respect for the past and how things were done originally, so that effectively we are trying to keep the quality and the pride in the property and the ironwork, the whole aspect of what was originally there, put there by craftsmen originally. We're putting it back again.
Is there anything that you wouldn't or can't tackle?
We've tackled all sorts of amazing structures and projects, but everyone is dealt with individually and with that same enthusiasm for the detail that is so often omitted because of ignorance, that things are available, we can put things back as they used to be, and it's half of our pleasure in the work we do to get it right.
This way is our historic environment protected for generations to come.